Okay, so here's just a quick video on all the different angles of a polygon that we have talked about in class, and I'm going to start with central angles and the sum of all the interior angles, because those are the two that it doesn't matter if it's a regular polygon like the one we see here, or if it's irregular, kind of like maybe a shape like this one here, where it kind of just looks like it doesn't matter if the sides are the same, or if the side lengths are the same, or if the angles are the same. That would be non-regular. And these two first ones, doesn't matter if it's regular or irregular. And those two would be the central angle, and the sum of all the interiors, the sum of all the interior angles. These two, it doesn't matter if it's regular or irregular. They always are found like this. For central angle, remember, is this angle here in the middle. And to find that central angle, what we need to do is we need to take 360 and you need to divide it by n, or you need to divide it by your number of sides. If I'm looking at this shape here, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's got 10 sides, and it doesn't again matter if it's regular or irregular. It's a 10-sided shape, and so what you do would be 360 divided by 10, and that would give me that the central angle is 36 degrees. Okay. For the sum of the interior angles, is, and which just again, an interior angle, or the sum of all the interior angles would be the sum of all of these angles. Sum of all these angles inside of it. And if I want to find the sum of all those interior angles, what I need to do is n, the number of sides is n, minus 2 times 180. Okay? And so if I plugged it in here, what I would have would be, it's a 10-sided shape, so that's 10 minus 2 times 180, which would tell me that that's 8 times 180, and that would give me 1,440. And so the sum of all those angles, all these black angles on the inside, if you added them all up, the sum of those would be 1,440 based on that formula. All right. Now I'm going to go into the rest of the ones that we've talked about, and the rest of the ones we've talked about, it has to be a regular shape. So it has to be like this one here, where it has all equal sides and all equal angles. When you have a regular shape, like the one on the left, you can find just one interior angle. Instead of finding out the sum of them all, you can find just one interior angle, and to do that, you would need to do the same kind of equation, n minus 2 times 180, but this time you take that equation and you divide it by the number of sides. And so if we plugged it in again, we would have this 10 minus 2 times 180, and you would divide that by 10. Well, we know that the numerator, from what I just did, the numerator gives me 1,440, and I divide that by 10. And that tells me that all of the inside, or the interior angle, just one of them, would be 144 degrees. All right, and again, to be able to use that equation to find just one interior angle, this has to be a regular shape. And so that tells me that this angle right here is 144 degrees based on the math I just did. Okay. The other one we have done is exterior angle. I think exterior angle is the last one that we've talked about. And to find exterior angles, there's two different ways. If it's a regular shape, so let me put that up here, exterior. If it's a regular shape where it's got all equal sides and all equal angles, to find this exterior angle here, this is your exterior angle. To find that exterior angle of a regular shape, you can take 360 and divide it by the number of sides, because I know the sum of the exterior angles of a regular always add up to 360. And so the exterior angle, if this was 10-sided, would be 360 divided by 10, which would give me 36 degrees as an exterior angle. The other way to find an exterior angle is if you use the interior angle. And from what I just saw, this interior angle here was 144 degrees. And so another way to find exterior angle is to take 180 degrees minus your interior angle. And if you do 180 minus your interior, you'll always get your exterior. And so saying like if that interior angle is 144 degrees, what I can do is 180 degrees minus 144 degrees, and I get that my exterior angle is 36 degrees. Either way, either one of those methods works, but it has to be, again, a regular polygon for that to happen. I believe that's all the angles that we've done in class. Central angle, the sum of all the interiors, just one interior and exterior. If I missed one or if I didn't explain it fully, let me know. I'm going to do problem 135 now. So problem 135 is this distance around the track, and it's really talking about circumference because circumference is the distance around a circle. And what we have here is really two half circles that we can combine to create a whole circle. And so the first thing I kind of want us to do is like imagine if we could take out, we'll add it back in at the end, but imagine if we take out this middle part here. If we take out this middle part and we combine these two outside parts of the track, we actually do have two different types of circles. We have two different circles. We have a smaller circle that has the radius of little r, and we have this bigger circle that has the radius of big R. And what we want to do is we want to find the circumference of those two circles, and then we kind of want to add the straightaway of the track, because in either case, whether you're the inside runner or the outside runner, you still have to run that 100-meter straightaway. The distance only changes because of the inside circle and the outside circle. So the first thing I'm going to do is I'm going to find the circumference of the small circle, and then I'm going to add the 200 meters, 100 meters from this straightaway, and then another 100 meters from the other straightaway. And then that's going to be the total distance that that inside runner has to run. And so to find the circumference of the small circle, I need to use my circumference formula. My circumference is always equal to 2 times pi times the radius. And on the small circle, my radius is equal to 30. And so what I get for a circumference is 2 times pi times 30, which gives me a circumference of 60 pi. 60 pi as a decimal, because I just kind of want to work with decimals here, is 188, about 188.5 meters. And now I'm going to add the two straightaways from that. So I'm going to add 200 meters based on the fact that they have to run these two straightaways with it. And so I'm going to add 200 meters to this based on those straightaways, and that total distance that the inside runner has to run is, sorry, plugging it in my calculator quick, is 388.5 meters that inside person has to run. Okay, now we're going to see how far the outside person has to run, and it's the same kind of idea. Our radius this time is 33. And so I'm going to use the circumference equation again. Circumference C equals 2 times pi times radius, big radius. And I'm plugging things in. I get 2 times pi times 33. Sorry, my work's kind of getting crammed here. If I plug this in, I get a circumference that is equal to 66 pi. And again, I'm going to go into decimals. 66 pi is approximately 207.3 meters. And then I'm going to add again 200 meters for the straightaways, these red straightaways. And I'll have my answer for the total distance of the outside, so plus 200 meters here. And I should end up getting that the total distance around the track for the outside person was 404 407.3 meters. And so if I want to find the difference in the distance those two people ran, I'm going to take the big outside runner and subtract the inside runner to find the difference in those two distance traveled. So 407.3 meters minus 388.5 meters. And I will end up getting, sorry, I'm going to use my calculator here, 407.3 minus 388.5. And the difference is 18.8 meters. And so the person on the outside of the track, the person that had to run on the outside, had to run 18.8 meters than the person on the inside. And just to recap the big ideas here, I found the circumference of the circle because I kind of took out this middle part to start. I took out the middle part and I saw it as a circle with small r and a circle with big R. Then I found the circumference of those two circles and I made sure to add 200 meters to both of them because there are 200 meters worth of straightaways that I was cutting out from the circles. So I had to add it back in at the end. And by finding the circumference and adding those two straightaways, I found the two distances around the track. I saw that this person definitely had to run in red, had to run a shorter distance than the person that ran on the outside, which was in black. Then I took the big distance minus the small distance to find out that the person on the outside had to run 18.8 more meters. I hope this and this idea of all the different angles of a polygon helps.